Okay, we're going to go over some of those even examples that we referred to earlier in the lecture today on the linearization function. This is a function that we're going to use today for those even examples. And we started to talk a little bit about them. So we're going to go all the way down to the even examples. And that way you can have additional examples to look at and consider. So here we go. Again, we're going to approximate the function 1 over x. This is our f. So we're going to approximate the function that gives us this expression 1 over 1,000. And as we talked about earlier, we're going to do it about the value a being 100. So if our function is 1 over x, the derivative of such function, right? Because remember, this is going to be, x to the minus 1 power. By power rule, this is negative 1 minus 1, which is negative 1 times x to the minus 2, which is negative 1 over x squared. So this is why we got our derivative function to be minus 1 over x squared. So the linearization function is f of a plus f prime of a times x minus a. So we have all the information we need to approximate the function 1 over x about the value 1,000. So here's our linearization function. F of 1,000, that's the a value, plus negative 1 over 1,000 to the second power, x minus 1,000. And let me go back and do this notation so you guys can see this. Okay, so we just plugged in the value of a into our linearization function here. This is a is 1,000. What that now means is 1 over 1,000 plus negative 1 over 1,000 to the second power. That's going to be interesting. X minus 1,000 here. Okay, here's the linearization function. So maybe we should just write it this way. Maybe we do some simplification. 1 over 1,000 minus 1 over that 1,000 squared x minus 1,000. So here's what we're going to do. We're going to try to plug some of this in the calculator. Maybe that'll be helpful. 1 over 1,000 here, we'll get 0.001 minus, now we'll have 1 over 1,000 to the second power. So we're going to look in the TI here. This is 1 over 1,000. So 1 divided by now 1,000 to the second power here, right? We're going to get that decimal value. And that's scientific notation. That's 1 times 10 to the minus 6, which means you're going to have 5 zeros in front of the 1. Okay, you got to move that decimal 6 spaces to the left here. So I got 1, 2, 3, 4, 5 zeros and a 1. Now this is x minus 1,000 here. And that's your linearization function here. Okay, so we're going to approximate 1 over x. So this function is approximately 0.001 minus 5 zeros, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1 times x minus 1,000. That's the whole idea. So the original question now is to approximate 1 over 1,002. This is what they're asking here. So this value here now is what we're going to use here. This is our our x value, 1002. So I can approximate, if I plug in now, 1002, wherever there's an x, this is how we use the linearization function. So 1 over 1002 will be approximately 0.123, 2 zeros and a 1, and then 5 zeros. 1, 2, 3, 4, 5 zeros and a 1. 1002 minus 1000 here. And of course, this portion here will be the value 2. So that's 2. So let's punch this in the TI now. 1, 2 zeros and a 1 minus 1, 2, 3, 4, 5 zeros and a 1 times, really times 2. So I'm just going to go back there. Let's see if I can delete that. There we go, times 2. And this is what we're saying here now. 1 over 1002 is approximately, this is again scientific notation. If we look at the TI calculator, 9.98 times 10 to the minus 4, we're going to move decimal place 4 spaces to the left, which gives me 3 zeros. 3 zeros after the decimal now. 1, 2, 3 zeros. And don't forget the digits are 9, 9, 8. Okay, so here's the ratio 1 over 1002 by using the linearization function. And then notice the calculator is going to say, if we divide this, that this is the answer. And so it's pretty much the same answer. You have some extra values there, but it's approximately the same. So ladies and gentlemen, we are on the right track there. If we look at this TI, 1 over 1002, 9.98, and then you have some extra digits times 10 to the minus 4 power here. Okay, and that's pretty similar here to what we have here. So that's kind of what they want you to do, ladies and gentlemen. It's a pretty good approximation. So that's how we handle question number 2, the first even function. We did 3 earlier. And we started to talk about 4 here. Okay, so we're going to approximate secant. But we're going to approximate secant for the a value of not 0.08, but the a value now will be 0.10. And notice this is a radian measure. So these are in radians. So the derivative of secant is secant tangent. We don't have to convert because it's already given in terms of radians, a real number for secant. So our linearization function, by definition, we can approximate secant f of a plus f prime of a times x minus a. And this is good for x near a. So in this example, we're going to plug in, and let's be careful. Yeah, 0.10 for a. 0.10 for a. Let's double check. There's your a value. Now, this is secant 0.10 plus secant tangent 0.10. We're going to run out of space. Secant tangent 0.10 x minus 0.10. Okay, so here's our linearization function. I guess we'll just leave it at that. Okay, so let me put that L of x there. I won't bother getting the numerical values at all for secant and secant tangent and such. All right, now we want to approximate. If we just go back, we could just mention to you that what this is, just so we can be clear, is that the secant function is approximated with secant 0.10, and I'll put it down here, secant tangent x minus 0.10. Here's your approximation here. Let's clean this up. So this is what we're approximating with a nice linear function. Now, the value of x, because the original question is right in here, use 0.08 now. So I don't know, I guess I'll change the color here, use 0.08. That's already a radian measure, so we want to find what secant 0.08 is. Radians, 0.08. So plug in 0.08 for x. So here's what this gives you. Secant 0.08 will be secant 10 plus secant 10 tangent 10 times the difference between 0.08 and 0.1. Okay? That difference, 0.08 minus 0.1, is minus 0.02. So this is the difference we're talking about. That's minus 0.02. So I can put the 0.02 here factor, but make sure that this is now negative here. Okay, so this is how we're going to approximate secant 0.08 in terms of radians now. Okay, so that's going to be there. Now, this is that linearization function here on the right side. So we're going to now need to evaluate in our calculator values of like secant and tangent of radian measure values. This has to be in radian measure. So I have to make sure my calculator is in terms of radians. It's in degrees, so I want to change that. So I just hit enter and I changed it. It's now in terms of radians now. Okay, so let's double check. Is that in radian measure? It sure is. Okay, good. Radians, not degrees. So we're going to enter all of this here. Secant of 0.1 minus secant 0.1, tangent 0.1, 0.02. The secant key, there might be a secant key if I dig somewhere, but I'm going to have to use the reciprocal. So here's what I'm saying here. Secant is the reciprocal of cosine. So I'm going to use 1 divided by now cosine of this 0.1, and that's going to be what I use for my secant here. So if I look back at the iPad, that's really secant of 0.1. Okay, now I'm going to have to do again, now minus, this is going to be a factor of, you know, you could put that minus 0.02 now times a parentheses. You put that factor first. You know, so I'm going to put that factor of 0.02, you know, because it's a number before my secant tangent now. So now I can say, okay, parentheses 1 divided by, this is supposed to be secant, so I'm going to use cosine. No. Go back and delete. Okay. 1 divided by cosine 0.1, and that's secant. Close that reciprocal times tangent of 0.1. So this is what we're entering in the iPad here. minus 0.02 secant, which is really the reciprocal of cosine, and then times tangent. So hit enter. We get 1.003 0.0415 by the linearization function. See what my linearization function gives me. Okay, 1.003 again by that linearization function. Now, if you go to the calculator here and just put the reciprocal of, well, put secant, which is the reciprocal of cosine, you say 1. No, that's not what I want to do. 1 divided by cosine. This is secant. You say, what if I just did it from beginning of 0.08, right? Notice you're going to get a value that's pretty close. And again, this is approximate here, right? We just put 1 over cosine 0.08 in that calculator, you get 0.10032085556, and that's close to what you did by the linearization function. So that's what we want to do. We just verified that 1 over cosine here, which is secant, 1 divided by that cosine. I'll do it again, 0.08, and ladies and gentlemen, you know, that's secant of 0.08. So that's kind of what we're verifying here. And there you go. So that's the next even example. So this is even. And I don't remember if there's another. It looks like there's not. So it looks like we're done here. We did, there was 5 examples here of what we had to do here. So anyway, ladies and gentlemen, this is the evens 2 and 4. And I hope you enjoyed this demonstration. And I will post it on my website. And I'll send it to you guys in Canvas.